All right, so your programming test 1 will be tomorrow during your enroll session. I believe for you guys, it's going to be 1 p.m. So please just wait outside. We'll let you in like last time, about 5 to 10 minutes before. Okay, so you'll be guided for sure. My best advice for tomorrow, try to redo lab number 1 and also try to redo practice test 1. Maybe set yourself some time limits. I'm pretty sure it will help, especially for practice test 1. And just in case you don't know, we actually posted on the lecture site the recording from last Friday's review session. So it was it's actually quite a thorough session hosted. So feel free to check it out if you need any guidance on some parts of the solution. You will also see the Java solution on the E-class as well. You can also check it out. So whichever way that works for you. And then for lab number 2, and just make sure you keep working on that. I think I already got some very good questions from your fellow students, so just keep working on that. It's going to be very beneficial for the next programming test, right? It's coming. Any questions in general? All right, sounds good. We got one more class before the reading week. So during the reading week, I'll try to host some maybe a special office hour just in case you want to speak to me. But otherwise, you should really just do your catch up, for other courses as well. For that one, I'm not going to bother you too much. But I will let you know exactly what you can expect after the reading week. Alrighty, let's do a quick recap, and then we'll continue. Okay. So today, we're going to do quite a bit of tracing, especially about execution flow. But let me just remind you about what we had last time. So last time we actually talked about the different execution flow about normal versus abnormal, especially if you got a try and catch block versus if you don't have try and catch block. So these are very important 4 scenarios you want to watch out for. So I may not repeat them, but just make sure you study them, right? It's going to be very important conceptually. Actually, we're going to use many of them actually today to really understand what's really a good design for a test. The idea itself could be a little bit confusing at first, so you definitely need the knowledge and some basis about understanding flow. But we'll see that. We'll do lots of examples today. And this is the example we also trace in detail. So just notice that when you combine the loop together with maybe some try and catch, how are they actually combined together to work, especially about the different execution flow. You want to really pay attention to, especially when you're making this method call over here. When E throws the exception, you're going to go to the catch block. When it does not throw the exception, you're going to go to the next line and change the Boolean variable to be true, right? That's something we kind of traced last time. You want to really understand really why it should be programmed that way. Okay, and then version 1 is actually much simpler. So that one you can just do as exercise, either on the paper or maybe just without even writing that down. That'll be okay. I'll leave the choice to you. And then we talk about the bank example here. This one here also just a chain of method called about 3 methods. So we got 1, 2, and 3. I think the main line for you to pay attention to is this line right here, right? You can see we are referring to the accounts, which is an attribute declared to be an account array. So when you index into that particular array, that should really give you just account, like individual elements. So when you got account, you know that this withdraw method should come from the account class, right? So that's the reasoning I want you to know, right? So maybe it says something you already have seen in other contexts, but just make sure whenever you see anything like this, you will be able to understand what it is supposed to mean, or even write one yourself, maybe in the test, okay? And this example here is just about multiple catch blocks. So the assumption we are making is, let's say you have a single try block right here, and then you got multiple lines. Each one of them is a method call, and each one of them may throw a different kind of exception. Our assumption is that different kinds of exception, they are simply independent of each other. So that means for the catch block, that will catch them. It doesn't really matter about the order in which you kind of arrange about the catch. You can either try to do invalid transaction exception maybe first, and then negative radius exception next. Doesn't really matter about the order. Okay? And we kind of trace about different test cases. For example, let's say if the exception has been thrown from here, it's going to go to this catch block. On the other hand, if this line here does not throw any exception, but instead this line throws that exception for the negative radius exception, then it will go here, right? So we talk about the different execution flow. It's all about tracing, about what's going to happen when the flow got disrupted by exception. Just pay attention to it. And then we got a final example, which is about using the parseInt method from the Java library. So this one here, you may not use it a lot in this course specifically, but I think it's a very useful method. In general, whenever you want to use any library method or method from somebody else, always pay attention to the header of the method. If that particular method may specify certain exception, you can actually take advantage of it to see if the exception might be thrown. Right? Again, you're going to use a try and catch block to see if the exception can be caught. Okay. Good. And then, okay, this one here, just about reviewing the try and catch block, the catch with specified syntax. So this is a running example we're going to continue today. Let me just recap very quickly so you wouldn't lose the important detail. We're assuming a very simple counter. At a runtime, counter is going to range from the value between 0, the minimum, all the way to 3, the maximum, right? At the minimum, if you try to do decrements, you should really expect some value too small exception. And also, at a maximum value, if you try to do increment, you will get a value too large exception. So you can see that for increment, it specifies this particular value too large exception, which means in the case of increment, it may or may not throw the exception, depending on what the current value for the counter is. Similarly, for decrement here, it also specifies the value too small exception. And in the case where the value is already the minimum, you're going to throw that exception. Otherwise, you don't throw it. So it may or may not throw it. Just remember about these two methods and the possible exception. And then we kind of started drawing this diagram here just to say we need 8 test cases in total. So we got 1, 2, 3, 4. We got 4 different counter values between the minimum and the maximum. Between from 0 to 1, 1 to 2, 2 to 3, we can all do increment. So there are three normal scenarios for increments. Symmetrically, we could go from 3 to 2, 2 to 1, 1 to 0. So there's another 3 normal scenario for decrement. So these are all the 6. So our call, so let me just go directly, same diagram. We want to pay attention to about the different scenarios. For all these 6 right here, okay, we want to keep in mind, for all these 6, in the test case, we don't really expect the increment or decrement to throw any exception. Value too large exception or value too small exception is not expected. Okay, this is very important. I'm talking about really expectation. So for each individual test, you really have to understand what's really expected behavior from the method that's being tested. Okay. On the other hand, if you look at the other 2 scenarios, okay, let me use a different color. Let's say this one here. When you try to increment when the counter value is already the maximum, or when you try to decrement when the counter value is already the minimum. In either of these 2, you do expect some exception to occur. That'll be the expected behavior, right? It's completely opposite to the blue one, okay? So let me write it down. So for this one here, of course, this one here, similarly. The value too large exception expected for the increment. And the value too small exception will be expected for the decrements. So the main thing I want you to just take away, just for this page over here, we're going to make it much more elaborate in the example. Whenever you're doing tests, one category of test could be you don't expect any exception to occur, in which case you just check to see what's the counter value, what maybe from 0 to 1, 1 to 2, 2 to 3, etc. Another category would be you do expect the exception to occur. In that way, you should really somehow expect to see some disrupted execution flow. But how do I actually use that disrupted execution flow and make the test pass instead of failing? That's something we're going to see exactly, right? So in this diagram here, just identify what test case really expecting exception and what test case does not expect exception. That's all you need to know from this diagram. Any questions? Okay, good. So today, I think let's do a little bit of, I think for the first half, I would like to just talk about some basic clarification of the concept. And then we'll talk about regression testing quickly. And then I'm going to summarize about certain important aspects about what the design of tests should look like. And then we'll take a short break. After a short break, we'll do lots of coding example. Okay, that's the plan. Okay, let's now start with this. Just to clarify some terminology here. So this is a typical JUnit test method you will write. So you remember the add test tag. So this is the syntax specific for JUnit 1.4. right? That's the version we're using. If you use another version, of course, they might be a little bit different. But let's say JUnit 1.4 that we're using, version 4. Okay. So let's start with the method name over here. It's called test. Okay. So this is what we call a JUnit test method. Okay. So it's a JUnit test method. And the row it's displaying is a caller. It's basically trying to call any method you want to test for its correctness. So it is the caller. Okay. So who is the callee? Let's identify that right away. So you can see right here, we are creating a context object of type myClass, and then we're calling the getValue method. So getValue method here, so myClass.getValue is the callee. So we call this the method under test. So this is the method under test. And at the same time, you can think about it is the method being called by the JUnit test method, callee. Right? We got caller, we got callee, right? And then let's talk about how do we somehow check to see if the expectation can be met. Okay? So let's say in the typical scenario would be about assert equals. And the convention goes like this. Assert equals typically will take 1 and 2 arguments. The first argument here will be the expected value, right? So this will be the expected value. Expected value versus the value that's actually produced by the implementation you're trying to test, which will be the return value here. So this one here, all the getValue is going to return some value back to you, right? You can think about this is the value produced by the implementation. And of course, the assertion is going to pass if these two values match, in which case we can say that the implementation is correct. Otherwise, it might fail. Right? There might be a mismatch. All right, so it's very easy to clarify. Let's just visualize this very quickly. So we talk about two methods over here. So let's talk about the actual implementation. So one way to think about the implementation is it's more like a black box, for which you don't really know the details about the code that's being written. Okay? So let me just draw the box right here. So this is the method under test. And in this case, it is the getValue method. Okay, right here. And it's more like a black box, which will take some input and produce some output. So you can think about input will be the list of arguments that you will take. Arguments. And of course, this is more like a special case where there's no input, but that's okay. In general, there might be more than one, or maybe 0 inputs. And it's going to produce some output. In this case, it's going to be the return value for accessor. Return value. So as far as the implementation is concerned, that's how we can understand it as a tester. So let's say, put it more general context. Let's say you're working a software team, software development team. Usually the implementer and the tester will be maybe different team members. So you really have no bias when you actually test somebody else's implementation. But in this course, typically, you might be the tester and also implementer at the same time. That's also fine, right? Just make sure whenever you're trying to test your code, try to have minimum bias possible. Okay, let's see one more. What about the test method right here, right? Let's draw that as well. So we have our JUnits test method right here. So that is the JUnits test method. And that one there is just called test, okay? Doesn't matter, okay? Just test. And that one there is actually going to take several inputs. Let's talk about output here. Output is actually easier to understand. Output from the test method is going to be either pass or fail. Right? Pass or fail. It's going to be pass or fail. You can think about in the most general sense. When you say a test pass, it's simply because the expectation is met. But we're going to talk about expectation in a more elaborate way a little bit later. Okay? So pass here simply means the expectation. The expectation is actually met by the implementation. But be careful here, expectation sometimes might expect some exception to occur. Expectation sometimes may not expect any exception to occur. So it really depends on the cases. We'll see that. Okay? Pass or fail for the outcome. What about inputs? Apparently, you can see the expected value should be one of them. So you can think about it's going to be the expected value, one of them, right? It's going to be the expected value. It's going to take that as input, first of all. So expected value. And then it's also going to take the information from the actual test. So you can think about it's going to take the arguments of the test. It's going to take the method itself. It's also going to take the return value. You're going to consider everything together, right? It's going to be all the input to the method. Exactly how it's going to run the input, you don't need to know. It's just part of the JUnit framework. But conceptually, you can think about all these information about the method is going to be fed in to the JUnit test method by the JUnit framework. Okay? So given all these, we can decide either it's going to be a pass or fail, right? Conceptually. So the main thing for you to take away, distinguish between the test method and also the method under test, number one. Number two, to also know about the expected versus the actual. So in this assert equals here is the simplest scenario you can think about because that one there you don't really expect any exception to occur. But later on we're going to see where you do expect some exception to occur. The code of the test is going to look a little bit more complicated. We're going to use some try and catch block. That's something we'll see. Okay. All right. Any questions about this diagram here? Okay. Okay. Good. All right. Next one. Okay. Regression testing. So this one here, you can also see a standalone diagram also on the lecture side. You can also feel free to print it out, keep it handy. I will highly recommend or encourage you to really try it out, this flow here, when you were developing your lab number 2 right away, or future labs. This arguably is one of the most sound software engineering principles to really follow, to really see how things can be done. I'll try to explain to you. Just go slowly, okay? Okay, so let's start with when you are trying to develop something into the model package. So we try to develop some code in some Java classes, and typically these classes will come into model package. Oh, sorry. Let me change it back. In the model package, and let's say we're developing a counter class, right? In general, maybe a class may have many methods. You don't necessarily have to wait until all the methods in a particular class is done, and then you write the test cases. You don't have to wait for this long. As soon as we said your class is testable, you should really start writing some test cases. Okay, I'll explain that in one moment. Okay, so let's say once you have done some Java code in the model package, you can then try to derive or try to come up with some JUnit test cases. So this is the step about derive. But the actual derivation of the JUnit test cases is kind of beyond the scope of this course, because typically in your programming test or in your lab, we kind of give you some starter test cases to start with. So we kind of design that part already for you. But just understand that realistically, you will also need to come up with some test cases yourself. Okay? So for those of you who might be interested, I'm not too sure if this course might be compulsory for you guys if you're in software engineering. It's called EECS2030G, like a software engineering testing course. Maybe that's elective, I'm not too sure. Anyway, so if you want to learn more about different strategies for deriving test cases, that will be the course to maybe explore further. So for this course, we don't really cover that, unfortunately. But the principle is, you want to make your JUnit test cases as complete as possible. Quantity is not what you're pursuing. You want to really make sure the diversity, how wide the range of the test cases are. Okay? As complete as possible. Of course, complete over here should be with respect to the problem description you're given. So let's say you're in the programming test or in the lab, you want to really read over the problem description, maybe in the PDF and also in the test comments very carefully to see what problem you're really solving, to work out what are the possible scenarios you have to cover. Okay? So with respect to the problem description. So you always have to make sure you get very clear about what the problem is you're trying to solve before you even start coding. It's very important, right? So don't really just try to think about you can save time by coding right away. Not necessarily. You want to have a good plan and good understanding. Okay, so problem description. All right, so let's say you do have some initial test cases in JUnits. So let's now put this one here. So let's say you got some JUnit test cases. Okay, so we say that this process here is called incremental developments. Okay, I'll also explain that. So this part here is called incremental developments. Incremental developments. Okay. Incremental in the sense that you don't really want to wait until you have finished all the implementation that's required and then write test cases. You want to test your code as soon as it is testable. Okay, I'll write it down. As soon as a units of implementation is completed, write and run. Write and run test cases right away. So this is why it's also called test-driven developments. You want to somehow use the JUnit test cases to always drive your developments, right? You always have a good set of test cases that tells you exactly what you're supposed to do for your implementation. So this is really important, okay? Don't wait until the end, okay? As soon as, all right? It's a little bit like maybe in the first year we said that you should always keep saving your file. You don't really want to say, I develop for 1 hour and then I save my file, right? We're now getting a little bit more, even more advanced. Not only that you want to save your file, you want to make sure everything compiles, but also you have to make sure you constantly try to write and run test cases, right? That's really something you guys deserve to achieve, right, at this level. All right? Let's say we got test cases and then we're going to run them, right? And we run the JUnit test class as JUnit application. And then there are only two outcomes, either red bar or green bar, right? If you get a red bar, that simply means you got at least one test case that failed, at least one. So red bar means you got at least one test that actually failed. Okay? And usually the test will fail because somehow maybe some expected value was not really matched. So some expected value is not met by the implementation. Namely, what you implemented in the model package, right? At least one. So at this point, what you should really do is go back to your Java model package and fix it. And the way you're going to fix it is, of course, you can maybe try to look at maybe just by your eyes, but it's not going to work in a long term, for a realistic project. You may just want to use a breakpoint and debugger. Breakpoints and debugger. I think on Friday we also kind of show you how you can use the Eclipse debugger and breakpoint to debug one of the test cases. You can also take a look. You can just want to keep practicing. So the more you can practice the breakpoint debugger when you're doing the lab, so during the programming test, since we cannot give you any help, so debugger and breakpoint might be your best friend to really find out what the errors are. Okay. All right. So if you actually get a green bar, okay, so that means all the test cases pass. Okay, let me also clarify this concept here. So if you get a green bar, that means all the current tests pass. All the tests pass. What does that entail? That entail your software right now is correct. However, it's a relative concept. It's correct with respect to the tests you have run. Okay? The software is, I'll put quote, correct relative to the tests run. Okay? So the quality, how high you might be confident about your software being correct really depends on the quality of your test. Okay? So at this point, all the tests you have, you got to make sure they should be diverse enough to cover, okay, I'll put a star here, running out of space, to cover all scenarios of the inputs. Okay, as we'll see very soon, by definition, a JUnit test method will actually pass if nothing bad happened. What would be something bad? It could be assertion failure, or it could be maybe some unexpected exception, like a null pointer exception will be maybe array index out of bound exception. So accordingly, what's really the simplest way to really pass a test? You simply do nothing. All right? So that would mean when somebody tells you that I managed to pass 1,000 test cases for my lab number 1, you want to be a bit more reserved about this claim over here. You really want to dive into what exactly are the 1,000 test cases. Maybe they're simply testing maybe the same aspect for the code. Maybe they're only testing one method or only 2 methods. Or maybe they simply do nothing in each of the tests. Right? You got to be really focused on the quality of the test. All right, so even though you get a green bar, don't be too happy. You want to be critical about what are really the tests that's being run. One more thing, just for explanation about the term. The term about regression, right? You might be wondering, why is it called regression? Okay? I believe it's kind of borrowed from the real life analogy. So, when you do reading, maybe back in elementary school, for us, right? So usually the teachers say you should really try to avoid regression. What does regression really mean? Let's say you got so many lines of the text in a page you want to read. So maybe after reading a few lines, you decided that I have forgotten about what I have read. So I will go back and then read over again. When I go around here, I also forgot again. Go back and read again. You don't really want to, when you do reading, you don't really want to repeat over and over what you have already read. You want to go just one go, one pass. On the other hand, regression is a very good practice for software developments. For the same set of test cases, you want to run them over and over and over again whenever you got any changes. Okay? So one more illustration. Okay? So think about for each, let's say here. Let's say every time, whenever you're trying to make some changes to your code. Okay? So maybe make some change to your code or your projects. And the change over here could be as small as maybe I'm simply trying to change one line of the variable assignments. Maybe I'm trying to create a helper method and call the helper method instead, right? There could be different kind of changes. Just make a change, okay? You want to always make sure, whenever you make a change to your code, before the change, assuming that you get a green bar for the JUnits, you actually get a green bar from JUnits with, let's say, n tests. You want to make sure after the change has been made, you want to rerun all the test cases right away and make sure what used to pass still pass. Okay, you want to make sure right here, all the n tests must still pass. So this is to make sure your change has not injected any error into your software projects. That's always something you want to make sure. Okay? So this change over here should not have injected any error to the existing code. If it has, in that way, you would have got a red bar. In that case, fix that change right away. Or undo it and try to see what you can do, right? Just always remember, you always want to make sure you get a green bar and keep expanding the test cases you have. Okay? All right, any questions about regression testing? Anything that's not clear? Okay. Yep, yeah, start practicing this. Just make sure you keep running the test cases. You can even add your own test case if you want to. Okay. Okay, one small thing, and then we'll talk about the design of tests. Just one small thing. Okay. This is something I kind of, just before that, so there will be some studies you want to do on the slides. So from slide number 12 all the way to 25, okay? So these slides are more like a tutorial slides to show to you how you can use the JUnit framework, which you pretty much learned from Lab 0 Part 1 already. It also includes some assertions example there as well. So I would suggest maybe when you study for your written test number 1 after the reading week, you may also just want to skim through the slide to see if there's anything you want to review. Okay, I'll leave the choice to you. But from slide number 12 to 25, I'm going to leave to you for self-study. Okay, they're pretty straightforward to go over. Okay, let's talk about this one here. Okay, so these two screenshots come from, this one here comes from slide number 16. And this one here comes from slide number 19. Okay, I'll talk about each one of them because they're so important to remind you. So this one here, which I kind of said that very briefly verbally, this one defines about what does it really mean when a test case will actually pass. Okay, a test will fail if any of the two happened. Number one, if some assertion failure. If you try to write assert true, if you write assert equals, assert false, etc., right? If they fail, you fail the test right away. Okay. There is one very interesting exception. One very interesting assertion here called fail. Okay. Maybe there's something you haven't used before, but this is actually a very useful assertion. We're going to see a lot today. Okay. What does fail really do? Fail usually you can call that assertion either using fail without any arguments, or you can simply say fail. You can pass out information inside. You can go either way. Okay? You can call the assertion either way. And fail basically say, I want to fail the test right here, right away, unconditionally. This will actually fail the test right away, unconditionally. So think about assertion failure is more like an exception being thrown in some way because the call stack is not going to grow any further. You're going to somehow fail the test. Okay? We're going to see many more examples about fail assertion. We'll get there. Okay? Another scenario that can fail your test is when you got some unexpected exception. Okay, unexpected. Not really the exception you created yourself and have to try and catch block. Not really. As we learned earlier, when you catch certain exception you have created, exception is no longer there. Okay, it's not that kind of exception we are talking about. So like a null pointer exception or array index out of bound exception. I think these two will be your focus for now. You really want to try your best to really program your maybe classes or method in a logical way so you don't really run into these two, right? So these two are something you want to avoid. Even if you run into them at the runtime, you may also want to use a breakpoint debugger to find out, right? Right, if neither assertion failure nor unexpected exception occur, then the test will just succeed, okay? That's a simple definition, just keep in mind, okay? So a very simple question here. When you first create a JUnit test class, maybe you have seen that when you follow through with me for Lab 0 Part 1 tutorial video. When you first create a JUnit test class, they are going to give you a default test right here. And then you will see that inside this test here, there's only one line in the body of the implementation for the test method. Right? You simply say fail. Right? This one here, you simply say, I want to fail this single test right away, unconditionally. So if you simply run this, let's say test counter class as JUnit's test class, you're going to get a red bar because the only test is going to fail right away. Okay? So this fail assertion here simply just gives you a warning to say, if you want to keep developing this class over here, you better fix this particular test method here. Right? Just a warning. So it's a very simple question for you. According to the definition right here about when a test should really pass or fail, how can I somehow make this default failing test method pass right away? What will be the simplest way? Do I need to implement something useful? Or I can simply do something trivial to make this test pass? Go ahead.
You can just remove the line 7, the fail line.
Yeah, exactly, right? So as long as we just do nothing in the test method, right? Good. So you can remove the line or you can simply comment it out, right? I can just comment it out. Let's say I do that. In that way, it will be as if this test method here is doing nothing. So you can see that we are testing nothing, but the test still passes. That simply means whenever you're looking at some test report, quantity about the test being run is not as important. You want to look at the quality of what's being tested, right? Okay, so here, once I comment this out, so the test doing nothing simply means the test will passes trivially. Okay? That's something you definitely want to avoid, right? You don't want to just maybe copy and paste a test doing nothing for 1,000 times and claim, I got a green bar with 1,000 test cases. It's not going to be very useful. All right, so the main takeaway is really about this definition here. Okay, just remember. Okay, assertion failure or maybe unexpected exception for now. Okay, there will be some kind of unexpected exception, more kind, like a class cast exception, which when we talk about inheritance. But for now, you don't need to worry. I just want to mention that to you. Okay. Okay, one more page of notes, and then we can take a short break. After the break, we can do all code tracing. Okay. Let's just kind of walk through the idea about a design of a JUnit test. Okay, let's talk about it, and then we'll take a short break. We still got about 3 or 4 minutes before halfway. Okay, so let's say we talk about the design of a test, and of course, for our context, it's going to be JUnit test. Okay, whenever you talk about the design for the test, always think about what does the test expect to really happen. Sometimes the test might expect some exception to occur, and some may not. So that's something you want to clarify first. So let's make it simple. Okay? So there could be one scenario where the expectation is some, let's say, certain kind. Could be value too large or could be value too small, right? Certain kinds. Certain kind of exception occur. So this will be one possible expectation. Okay? And then the pass and fail should be defined accordingly. We'll see. Okay? So that's one kind. Let's talk about another opposite kind, which is also legitimate. Another possible kind would be, let me put it here. Okay? Let's say the expectation is we do not expect to see that exception, the opposite, right? The expectation is certain kind of exception. You can say not thrown or not occurring, doesn't matter. Okay, let me just say not thrown. We don't expect that. Okay, so that would be another kind of expectation. Okay, so the pink and the green are different kind of expectation, and the pass and fail will be defined accordingly. So we'll try to understand these two scenarios on the paper first, and then we'll see some Java code. Okay, after the break. Let's now just lay out the different scenario. So think about the expectation. It's really about a test. And this expectation here is also about a test. And what I'm going to enumerate as a possibility will be what's going to happen by the implementation or the method under test. So what we're going to see here will be the behavior of the method under test. Okay, so these two, I'm going to just make a very quick point. So here are the possibility for method under test. Method under test, okay, which we'll see after the break. So let's talk about the different possibility. Let's say the method under test that kind of exception is thrown versus that kind of exception not thrown, right? So these are the two possibilities. And then I'm just going to copy and paste these two possibilities, okay? Let me copy this one here. And then I'm gonna, Let me do it again, sorry. There we go. And then I'm going to put it here. All right. So let's now take a look at this. For the test, we might have different expectation. For the test, the expectation could be we do expect the exception to occur, or versus we don't expect it. But now for the method under test, the exception may or may not occur, and also the exception may or may not occur. So now we have to think about 1, 2, 3, 4, the 4 scenarios, whether the test should actually pass or fail. That's something we're going to work out. Okay? Okay, I'll pause for a moment, and then we'll work out the answer. Let's say, just take one together. If the test is expecting the exception will occur, and that exception is really occur, in that way it should be a pass, because the expectation is met, right? Versus, I expect the exception to occur, but it did not occur. That should be a fail, okay? Because our expectation is not met. Okay, what about the other two, right? One thing I want to highlight right away. If you look at from the method's point of view, exception thrown here, and also exception thrown over here. Is exception thrown always give me a pass or fail? Always. Because, for example, exception is thrown from the method being test. Now, in this case, it's pass. What about in this case? Should it pass or fail? It should fail, because here, I do not expect the exception to occur, but it actually occur. The expectation is not met. In that way, I should really fail. And similarly, this one here is meeting the expectation. So it's going to pass. So the main point to really see is here. From the methods under test point of view, in the same scenario where the exception is really thrown, whether or not the test should be passing or fail really depends on the expectation. That is so important. So after the break, when we go over all the 3 test cases, we always got to keep in mind what's really the expectation we have from the method under test. That's something you want to keep in mind. Right? So that's a conceptual, like a enumeration about the different scenarios you want to keep in mind. Right? Any question on this? All right, if no, why don't we take a short break and then we'll continue, okay? Just get your iClicker ready and we'll take attendance. All right, so let's now go over code example in Java, right? So hopefully that can strengthen the understanding from before the break, okay? I got 3 examples in total just to go over, but each one of them got different scenario to consider. So for now, don't look at the Java code just yet, okay? Think about what we are trying to test. Let's say we initialize a counter, which has a minimum value 0. And then we call c.increments. So this one here should really go from 0 to 1 without any exception. So in this case, the expectation is we don't expect to see any value too large exception, right? It is so important for you to see that not trigger a value too large exception. So this is our expectation. Expectation of the test. Now, when we are testing this particular method here, increments, just remember the method here is kind of beyond your control. You're only a tester. You're testing for the correctness of the implementation. What if the implementation is correct versus the implementation not being correct? Your test should really handle both. All right? So this one here may or may not be implemented correctly. Okay, so now a good test should be as follows. If it is implemented correctly, that means the test should really pass. If it is not implemented correctly, then the test should really fail. Very simple principle, right? We're saying that when you are a tester and you're taking some method for testing its correctness. If the method is correct, pass. If method is not correct, fail. Okay, as simple as that. And I want you to take a look at this fragment of Java code right here to see why the setup of this test is actually going to achieve that when we don't expect any exception to occur from calling increments. Take a minute. Especially, I want you to pay attention to where we put the fail assertion. And think about what are the possible execution flow that might occur from increments. And I also need to remind you, this method here may or may not throw the value too large exception. It specifies the exception, so it may or may not throw it at a runtime, depending on the input value, really. All right, so everybody had a look, right? So now we got to see why the setup over here will actually be a good test. Okay, let's see. Let's talk about the two different execution flow. So I just duplicated the same test twice. Okay, so this are identical. Right? Let's talk about two scenarios. Let's say the increment method was implemented correctly. In that way, the value too large exception is not going to be thrown. No, all right? Because you're just trying to increment from 0 to 1. In this case, the value too large exception not thrown. Okay? Or maybe let me put in green. So green simply means it's correct behavior. That'll be a little bit better. So this will simply mean the value too large exception not thrown. And we know that it is the correct behavior versus the same method call, maybe from a different implementer. Okay? So this one here, the value too large exception is actually thrown unexpectedly. And we know that it is incorrect. So let's now see what the reaction is from the actual test. Let's look at the execution flow very quickly. If the exception is not thrown, that means we can go to the next line without any disruption. And we can simply go to the next line and we'll simply check to see the new value here has gone from 0 to 1. And then when we reach the end of the try block, we can bypass the catch block, and then we can reach the end of the test without any assertion failure, without any exception. In that way, pass. We never get to execute a fail assertion. On the other hand, in this scenario over here, if the exception is thrown, that means we'll bypass the rest of the try block. And then we'll go directly to the catch block right here, and then execute the fail. And this one here is going to fail the test unconditionally right away, right? So this one here is going to fail the test because the exception thrown is not as expected, right? Right here. It's a very quick overview about why this test over here is appropriate, because if the implementation is correct, it's going to pass. When it is incorrect, it's going to fail. But now let's trace it exactly, okay? Anyway, any question about what's here so far? Okay. Okay, let's now take a look for this one here. Scenario number 1. Let's say given this test and the implementation is actually correct. Okay, correct. And let's remind ourselves the expectation. The expectation is the value too large exception is not thrown. Okay, just keep that in mind. Okay, so now this is the correct implementation. But when the current value is equal to maximum value, then we throw that. Otherwise, we don't throw it. That's correct. Okay, let's now trace the code. Okay, so we're gonna create some counter objects, and then initially C the value is going to be 0, minimum. And then we're going to check to see whether or not it's really initialized to be the minimum, which is 0. In this case, yes, so that will pass, not a problem. And then we'll go into the try block, the first line. So we go to call this increment right here. So this increment here is a correct implementation, but let's now step into it to double check, right? So we step into it, and then number 4, we're going to check this if condition. So current value is actually 0, right? Initialized to be the minimum. And the maximum value is actually 3. 0 equals 3, false. So we don't really throw that exception. So that's a correct behavior. And then we're simply going to increment the value. It's going to be, this will be number 5, right? It's going to increment from 0 to 1, the counter value, right? So number 5 and number 6 is going to be, since we don't have any exception, so value too large, exception not thrown. That means we can proceed to the next line, which would be number 6 right here, okay? And then we make sure it is equal to 1. Indeed, that's something we just traced, right? So we have reached the end of the try block, and we bypass entirely the catch block right here. And then we'll reach the end of the test method. In that way, nothing bad has happened. No assertion failure, and no unexpected exception occur. It's going to pass. All right? So in this case, the test passed because the implementation does not throw the value too large exception as expected. Any question about this first scenario here? So we're given the implementation that's correct, right? The next scenario, what if the implementation you're given is incorrect? In which case, your test should not pass. It should fail. Otherwise, it's a useless test, right? Your pass shouldn't always pass or shouldn't always fail. You should really pass at the right time. So scenario number 2. All right, again, let's put the expectation here. Just remind. So the expectation is the value too large exception is not thrown. Okay, let's see. If it is thrown, that means we don't have our expectation being met. Okay, and I'm going to modify the implementation. So the correct one should be equal, but let me change that one to be smaller than, like that. Okay, it's a wrong one. Okay, let's now trace the same test. It shouldn't pass anymore. So what we do is we go for number 1, create a counter. It's going to have initial values. Counter value will be 0. And this assertion here will just check again whether minimum value 0 will match the 0. Yes, that's okay. Okay, go to the first line for the try block. And then we're going to go to see if this method here is actually going to trigger anything, right? We don't expect the exception to occur. However, let's see. This is wrong implementation. So step into it. So number 4, we're going to compare this if condition. The current value for the counter is the minimum, which is 0. And maximum value is 3. And if you compare 0 less than 3, true. Which means you're actually going to throw that exception unexpectedly. So this is unexpected behavior. Of course, at the same time, we're going to bypass the else part. Okay? So you can think about from line number 3, when we call the increments, the value too large exception thrown unexpectedly. Unexpectedly, right? This is so important to highlight it, unexpectedly. So that means we're actually going to bypass the rest of the try block. And then we're going to the catch block that will match the exception that's being thrown. And then number 6 should be the fail assertion. So now we're going to fail that assertion, fail that test right away. Okay? So it's going to fail. Okay? So the test failed because the implementation has thrown the value too large exception unexpectedly. All right, so what we have illustrated is for this particular test, it's a good test because number one, when you are given a correct implementation, it's going to follow the normal flow and pass it. And when you are given some wrong implementation, it's going to follow the abnormal flow and then fail it. Okay, that's the test. And the design of the test is really according to what the expectation is here, really important. Okay, because when the exception did not occur, you will be able to go to the next line. When the exception occurs, you're going to go to the catch block and then fail. That's a key critical point to really look into. All right, any questions about this test here? All good? All right, so now, example 2. Let's now flip the expectation. Let's say rather than expecting the exception not to occur, let's say we do expect the exception to occur. Okay, let me just erase that. Okay. Okay, let's now talk about the following scenario. Let's say the counter value currently is 0, and then we are trying to call decrements. In that case, the value to small exception is expected. So that's a new expectation we are trying to test. We're testing a different scenario, so expectation may be different. So this one here is the expectation. Okay, so this is the expectation. The value to small exception should be thrown. And then we want to talk about 2 different scenarios for the implementation. Of course, if the implementation is correct, we're going to pass. Correct simply means the value to small exception is actually thrown as expected. In that way, we're going to pass because we're expecting it. On the other hand, if the implementation is actually incorrect, meaning that it's not thrown as expected. So value to small exception is not thrown. In that way, we're going to fail the test. Okay, like that. Okay. Now, I want to give you 1 more minute. Can you please take a look at this new fragment of Java code? Again, pay attention to where the fail assertion is placed. That is so critical. In example 1, we placed the fail assertion in the catch block, but now we move it somewhere else. Right? So the fail assertion is moved right after the method call as part of the try block. But in the catch block, we simply do nothing right here. Okay? Let's now preview quickly about the 2 scenarios. Okay? So here we're calling the C.decrements over here, right? C.decrements and also C.decrements. Let's say for the correct implementation, the value to small exception is actually thrown. This is the correct behavior. Versus in the incorrect behavior, the value to small exception is not thrown. And we know that that one is not as expected, so that's incorrect. Let's just see very quickly about how the execution flow is supposed to flow. Okay? So let's say in this case, if the exception is thrown, that means we're going to bypass the rest of the try block. And then we're going to go to the catch block, and then we're going to execute the body of the catch block, do nothing. So nothing bad will happen. In that case, it will pass. Trivially, because nothing happened. On the other hand, if from this line over here, it is not thrown, that means we will be able to proceed to the next line. And we bypass the catch block, of course, at the same time. And when we proceed to the next line, we're going to fail that right here, unconditionally, because we're not supposed to. The flow is expected to have been disrupted by that value to small exception, but it's not there. Okay? So this one here is actually going to fail. So these are the two scenarios we have to make sure they can really occur, given the correct versus incorrect implementation, okay, to show that the test is actually good, appropriate. Okay, scenario 1. And let's remind ourselves what the expectation is. The expectation is the value to small exception should be thrown. Okay, that's what we expect to see. All right. Let's see for this flow here, and this is a correct implementation. So this is equal, right? That's correct. But you can, of course, you can justify that yourself to get yourself convinced what is correct. So we're going to go for line by line. So we go, number 1, create a counter value. So C dot value will be 0. And we do the same check to make sure initial value is simply the minimum 0. So that one, no problem. And then we go to the first line for the try block, number 3. And we're calling this decrements. Okay? So this version of the decrement is actually correct. So we're going to see, step into it and see. Okay? So step into it, we got number 4 over here. The counter value is actually 0. And the minimum value is also 0. So 0 equals 0, true. That means we're actually going to throw that exception, and this is the correct behavior for this particular test. So this one here is correct behavior. So this will be number 5. We throw that exception. So we go back to this method call. So we bypass the rest of the try block. And so you can think about the value to small exception is actually thrown from this line of method call right here. And then it's going to be caught by this catch block right here. You can see value to small exception. And then we're going to execute whatever that's here. Right? So conceptually, you can think about some things here. Number 6, I can just put 6 here. Just think about we just go in there. It's going to do nothing, so nothing bad will happen. No assertion failure, and no unexpected exception occur. So we're going to pass. So in this case, the test will pass because the implementation we are testing has thrown. The value to small exception as expected. So that is why it actually passed. Okay? So you really want to compare this test over here with the previous one. They got exactly the opposite expectation. All right? Any question about this one here? Clear? Okay, let's do the second one. Okay, again, let's remind ourselves about the expectation. Okay? The expectation, again, is the value to small exception is thrown. And we are given some wrong implementation. So I'm just going to inject an error. Rather than equal, let me say less than right here. Okay, just like that. Okay, it's a wrong implementation. Okay. Let's see how the execution flow is going to go for the test so that it's going to fail on this wrong implementation. Okay. Okay. One here, C dot value will be 0. Number 2, checking minimum 0 and the counter value 0, they match. Good. And we go into the first line for the try block. And we call the decrements right here and see what happened. And we step into it. So we check to see the value here. So value right now is 0. And minimum value is actually also 0, right? But now 0 less than 0 is going to give us false. Right? So that means we don't really throw that exception as expected. So we didn't meet the expectation. Instead, we're actually going to go into the else part right here and then decrement the value, which will go from 0 to -1. That's really bad. Right? And then at this point, no exception has been thrown. So the value to small exception not thrown, which is incorrect. In that way, we don't really get to the catch block because it's not, there's no exception thrown. So then we proceed to the next line. So number 6 over here, we're going to fail that test right away. The fact that you're able to flow from method call to the next line simply means the expected exception did not occur. So it's going to fail. All right, so our observation is the test failed because the implementation did not throw the value to small exception as expected. Okay, it's going to fail. All right, any questions about this? So far we covered 4 scenarios, right? You should really be very clear about pass and fail, okay? Depending on what the expectation is. Any questions? Anything that's not clear? So what can this be reflected in the actual test, for example? I might actually somehow state what the expectation is for that particular testing scenario, and then what you should do is, accordingly, think about how the try and catch block should be placed and where the assertion for fail should really be placed accordingly. That's something you should think about, right? So always be aware about what the expectation is. Okay, let's do one more. Okay, I want to be in sync with your fellow student from section B. Okay. Okay, this one here, let's now discuss that very quickly. Okay, so far we've seen 2 tests. In the first test, we do not expect the exception to occur. In the second test, we do expect the exception to occur. The third test, which is also possible, we say that some part of the test expect the exception to occur, but some part does not. So we have a mixed. All right, in that way, how do we set it up properly? Okay. First, let's now take a look at this. If you think about here, we got 2 try and catch. We got try and catch over here. We also got another try and catch over here. We got 2 pair. We got 1 pair. Wow, well, 2 independent try and catch blocks. And then what we have is we got initial counter value should be 0. So C dot value should be 0. And then, so here we intend to go from 0 to 1, and then from 1 to 2, and then from 2 to 3. And then we actually want to do another increments. In that way, we somehow want to go from 3 to 4. But remember, the maximum is actually 3, right? So I'll put a question mark over here. Okay? So now this could be an exam type of question. So now given this, can you somehow justify the expectation for maybe the first try and catch and the second try and catch? What exactly is the expectation? And why would we put a fail assertion in different places between the 2 try and catch blocks? How would you answer that? Okay. Let me rephrase the question. I'll let you guys think about it. We do have time. So I already kind of gave you the intention about each increment. We got 4 of them in total. 1, 2, 3, and 4. The first 3 increments are in the first try and catch. The last increment is in the second try and catch. The question is, are the expectations for the 2 try and catch blocks the same or different? And then, accordingly, why should the fail assertion be put differently in the 2 try and catch blocks? Okay, guys, think about it. You know, I'll definitely give you a chance to speak up, right? Just think about it. Programmatically, it's not difficult to trace the code because you can just go on, you know, to label each line. But however, to really express this kind of idea, right, in words, that would be something you want to also get prepared, maybe for the exam in December. Let's break it down. For the first pair of try and catch, let's say orange try and catch, what's the expectation here? Go ahead.
The increment thing doesn't throw an exception.
It doesn't throw the exception, I agree. So in the orange one, since we are incrementing 0 to 1, 1 to 2, 2 to 3, we shouldn't expect any value too large exception to be thrown. So why should we put a fail assertion in the catch block then?
Because if it does throw an exception, then it would go to catch, right? And then it would just
failed right away. Okay, very good. Okay, awesome. Okay, and in a very similar way, how do we understand the pink try and catch accordingly, right? Are they kind of interpreted the same way or it's a little bit different? Remember, when you reach the pink try and catch, the counter value would have been incremented to 3 already, presumably, right? And I'm saying that I want to do a 4th increment. Anyone? Want to try? If you know, go ahead.
This expects that we shouldn't be allowed to increment once more because the max is 3. So
Yeah.
if the increment is successful, then it would fail because it will go to the next line. If increment throws an exception, it will just continue with the test case fine.
So the expectation in the pink one is, do we expect or not to expect the exception? We do expect the exception, value to large exception. Exactly, very good. All right, so let me summarize what your fellow student, actually answered. They're pretty spot on. So that's really something you want to also get used to. We do have maybe 1 or 2 more exercises which we can do on Thursday again. But let me just write this down, and then we're good for today. Okay, we can let you go earlier today. So we basically got 2 phases. We got basically phase number 1 right here, and we got phase number 2 right here. We got 2 phases. Okay. So for phase number 1. Phase number 1, the value too large exception not expected. This is why, as your fellow student correctly pointed out, if it did occur, you're going to fail in the catch block. Okay? On the other hand, phase number 2, right here, given that the value is already reached the maximum. So phase number 2, the value too large exception is expected. So this is why if you're able to proceed to the next line, that means the value too large exception has not occurred. In that way, we should really fail that. Okay? So that's why it's actually here. All right, it's very important to actually understand about where you put the fail assertion, right? Very important. Right? Guys, any questions? Okay, if no question, you guys I'll let you go earlier today, and then I'll see you tomorrow at 1 p.m. in the William Small Center. Okay, just be there in time, and I'll see you there. Be well.